Hello, everybody, and welcome to Industrial Automation. It doesn't have to. In case you're new to the program, I'm Brandon Ellis. I'm your host and also the owner of elliTek. As we jump into the episode for today, I want to ask that you hit that follow button and subscribe button based upon the platform that you're listening on. And if you're listening specifically on Apple Podcasts and Spotify, and you enjoy what you hear today, leave us a 5-star rating and review. We sure would appreciate it. Now that we've got the marketing out of the way, I just want to say thanks for tuning in. So, let's get started. Hey everybody, welcome to Industrial Automation. It doesn't have to. It's season 4. Welcome back, Beth.
Hey, welcome back, Brandon. Happy New Year.
Yeah, Happy New Year to you. We had a holiday season.
Yes.
We had, I guess, Thanksgiving. Of course, we spoke to the folks after Thanksgiving. Yeah. We spoke to them before Christmas. Mm-hmm. But we didn't speak to you with the New Year.
That's right.
So Happy New Year.
Happy 2022.
2022,
Hey.
That's right. And so, wow, what a year. And as we sat here today, we still are reeling from some of the 2021 things. And so global supply chain still here.
Yeah.
We toasted away 2021, and now woke up 2022. And guess what? We still have global supply chain issues. Unfortunately, the experts, hopefully they're wrong, says it's going to get worse. So hopefully it doesn't get worse. The second thing is, let's see, 2021 took us through the Delta variant. That's the one got most of the press, and then brought us into Omicron. Mm-hmm. And now the latest thing is the media. I don't know if the media is doing, because this is not, they're making up words now. They're making up letters of the Greek alphabet. Deltacron.
Does that sound like a transformer to you?
It does. So it's like Delta's bad, Omicron's bad. Let's make the worst so we combine the two. It's almost like something, quite honestly, that my nieces or nephews would have done back when they were young, or me when I was young. Combine two words that are bad, and it's really bad, right? So Deltacron.
I think if you put Deltacron X.
That's right. So let's see. We haven't gone through our sounds. That's still the applause that sounds like rain. We can't seem to do anything about that. That's the laugh track. Okay, we got that. And we got the that was the acronym.
Oh, that's right.
Yeah. So we have some new ones here.
Okay.
So
game show.
Game show. Deltacron. And then that's
the thinking.
What's worse than Delta and Omicron? Yeah, that kind of works. Or Deltacron. So we got a couple of new sound pads this 2022. So we'll have some fun with that. But today we're going to talk about some cool things that are happening with us. So the other thing that happened with elliTek, or I'm extremely proud to I guess announce. Well, you've been announcing it for the last month, or it seems like weeks, months, a whole lot. And that is a new distribution line that we have, which is CKD. And CKD is a very well-known pneumatic line for their pneumatics, their pneumatic grippers, pneumatic valves, pneumatic cylinders, things of that nature. Tons of quality there. We really like them, especially with their manifolds, with the steps that they've made. But the steps that they made, that for me, because I'm a electrical controls guy more than mechanical folks, which pneumatics typically more mechanical, is the innovation that they've come up both mechanically and electrically with their electric actuator product, and they're also their pneumatic manifolds with new supporting new Fieldbus technologies with their manifolds. So pneumatic manifolds, usually we just wire to those. Manifold means one air line in, one air source, primary air source, and then we have stacked up various sizes of valves. Valves can move more air or less air based upon their size. So you stack them all up on a manifold, which means instead of running an individual airline to each one of those valves, you run one primary airline to the manifold, and then it sources air to each one of the valves, and then you control the valves individually, usually from the PLC or something like that. And so you can do that with wiring, but then it's a lot of wiring. You can instead of wiring, you can do it with Fieldbus. And so Fieldbuses are commonly referred to, or most common Fieldbuses, at least in North America, is going to be Ethernet IP, Modbus TCP, EtherCAT, Profinet. Those are examples of various Fieldbus technologies. And so CKD does that very well, and they support quite a few. They also support serial-based Fieldbuses, which is DeviceNet. CC-Link is maybe not as well known. That's a Mitsubishi protocol. And then so DeviceNet, CC-Link, and then Profibus.
Okay.
And so that's some cool things that they do with their manifold. But on their electric actuators, they also support all those Fieldbus interfaces. So if you run a control, now electric actuator. So now this means that we have a ball screw actuator. It's a compact and smaller. So we're talking smaller payloads, smaller strokes. We've talked about our Yaskawa Tolomatic product where we put those together. We're doing extremely high force projects with those. In fact, we've got one right now we're working on with a customer, and we hope that we're going to be able to do that. We're going to be pressing forces up above 12,000 pounds.
Oh my word!
So that's what we do with the Tolomatic and the Yaskawa stuff.
The
heavy
duty,
big. We can go all the way up to big. We can do small stuff, but we can go up to big stuff. But CKD handles the small stuff very elegantly and robustly. And that's what I like about it. I like the fact that with their electric actuators, and there's other electric actuators out there, these small, what I call compact electric linear actuators.
Now, define compact, because when you were talking compact, I thought small.
Well, they are smaller, but that to me, that means the motor, the coupling, connected to the screw, all that's built together as one thing.
Okay.
So with the Tolomatic Yaskawa solution that we would engineer, Tolomatic coming from Tolomatic, Yaskawa coming from Yaskawa, and then sometimes, according to the type of actuator and type of application, maybe even a Nidec Shimpo gearbox in between those two. But you would have a motor connected to a gearbox, connected to a coupling that couples that to the Tolomatic actuator. When I say compact, I mean all that's built together. It's sized, it's constructed already, so the sizing is based upon what you've got.
Okay.
And there's different sizes, but you don't have to get to the point of saying, what motor am I going to use? What gearbox am I going to use? What actuator I'm going to use? They're already put together.
Okay.
And so that's what I refer to as a compact, maybe I should say configured, electric linear actuator.
Okay.
And again, usually we're talking about strokes that are 400 to 500, maybe 600 millimeters and below. Millimeters.
Okay.
Okay. And so we're not talking huge thrust or anything like that. But if we're moving parts, if we're doing basic machine setup, if we're doing simple pick and place, we can certainly do it with these actuators. And so why can we do that? Well, as I was saying, there's other compact linear actuator companies out there. Some have been around forever. Some have been around forever, but are just now starting to really find their way. But CKD's been doing this for a bit of a while, but they've done it correctly. So from a mechanical standpoint, their actuators actually have a linear, what we call a linear rail. It's basically a linear ball bearing mounted inside of the actuator, which means for you mechanical folks out there, moment loads, thrust loads, payloads are all taken care of by that linear actuator. There's a rod type and a rodless. Rodless means that you just have a carriage that's sliding across the length of the actuator. And since that's supported internally with this rail, you don't need an external rail. Usually we have to add this external ball rail to kind of support the moments. Well, it's built into the actuator.
Ah, smart.
And that's nice. It's really nice. The second thing is, and what other folks do instead of that, though, is they may have recirculating ball bearings, but they're really just going through hardened races that are pressed into the aluminum body of the actuator. It's not an actual real hardened rail down the center. And that's a big difference. The second thing that I really like that they do from a mechanical standpoint is there's different sizes, so there's different sizes, diameters of fasteners that you would use to mount these things. But one of the things I really like that they do, and I just thought, man, that's the slickest thing ever, is most of them are just what we call through hole. That means it doesn't have threads inside the hole. It's just a drilled hole, okay, a drilled or machined hole going through. And so you have to put a fastener through that, and then you'll screw that into some type of a mounting surface that's drilled and tapped, which means it has threads in it to tighten down the actuator. So that's a top mount. Sometimes you have to remove covers to do that and stuff like that. With them, you don't have to remove covers. So that's always better.
Yeah.
But what if you need to install the actuator and you really want to do a through hole in the plate and come in from the back or the bottom and have threads in the actuator body? Well, they solve that. And the way they do that is they tap the actuator for a larger diameter fastener. So in one of the sizes, the through hole is usually a through hole for a 3 millimeter bolt.
That's what typically is done?
That's a typical within a certain size. Now, again, if you go up on size, that becomes a 4 millimeter through hole and things of that nature. But let's say that it's most are a through hole for a 3 millimeter, which means it'd probably be a 3.5 millimeter diameter hole.
Okay.
So the bolt with the threads can easily slide through. They'll tap it for a 4 millimeter bolt. What that means is your 3 millimeter screw, if you want to go from the top down into a threaded hole in the plate, can still be 3 millimeters. But if you want to come from the bottom of the plate up through a through hole in the plate into threads into the actuator, you just use a 4 millimeter screw.
Oh, that's ingenious.
Well, it's easy. I mean, it's one step because you're adding threads. Because the truth of the matter is, if you're gonna tap a 4 millimeter hole, you're gonna drill it to 3.5 millimeters and tap it. So they're just adding the tap step in there. So it allows you to, again, do a top mount using a smaller diameter fastener, or do a bottom mount using the threads in the actuator, using the next step up on the diameter. And so it's just, to me, it just makes, I actually have had situations years ago where we had to come through the plate. So we had to tap the actuators. In tapping the actuator, we voided the warranty.
That's what I was going to ask.
But we had to do it because we had to do a bottom mount. Okay. This allows you to choose.
Oh,
so
nice.
That for me, because I'd had that experience before, nothing's worse than buying a brand new thing as a machine builder or integrator, or asking your customer, if they're the machine builder or integrator, to void the warranty.
Yeah, no kidding.
So that's one of the things I really like about the CKD and the linear rail. But then the next thing is the Fieldbus protocols. So we can do parallel I/O, which is fairly common, and also not everybody can do this. They have a valve mode. So if you are becoming more green, let's see. Yay, more green, right? Like the earth. If you are becoming more green, and a lot of companies are moving toward more energy efficiency and things of that nature, one way to do that, and it's been proven, a lot of people argue about this, but hey, it's been proven. The facts are out there. Compressed air costs more to manage, maintain because of leaks, because especially if you're big enough, and in a lot of larger places, we don't run a compressor that comes on when you need it and goes off. It's a screw compressor, which is running all the time. Mm-hmm. So all that energy that's being spent, and all the leaks that are, because you're trying to store in airlines and things of that nature, store compressed air, there's always leaks, there's always inefficiency. Mm-hmm. And there's certainly advantages to air over electric, but for the most part, we can emulate very closely air with electric. So if all you're wanting to do is not change anything, just pull out this cylinder, and I talked about rod type versus rodless. Rodless is the carriage running along. Rod type is like a pretty typical pneumatic cylinder. That means you have a cylinder, and inside of that you have a smaller cylinder that comes out, extends out, or goes back in.
Okay.
And so that's what we call a rod type actuator. Well, you can get those in electric, just like the slider types. So if your goal is just to replace pneumatics, you might even be able to find, we might even be able to get you one that's just a drop-in as far as mechanically, but you pull out the pneumatic one, disconnect the air. Air's coming from the valves, all that kind of stuff. And you put in the electric. So you will have a control, but you can put that control in valve mode, which means the same outputs from your PLC, you don't have to reprogram your PLC. You just use the same wires to wire to the controller, and you teach. This is the extended position. This is the retracted position. And when that valve turns on, it'll go out. And when it turns off, it'll come back. And we call that single solenoid. So in pneumatic world, single solenoid means that when I put power on the valve shifts. The air moves into the cylinder so that it extends or retracts one direction or the other. And then when I take power off, a spring will push the valve back to the other position, which means the air shifts. And so now it comes back the opposite direction. So that's single solenoid mode. So they have a single solenoid mode. Sometimes on valves with pneumatics, we do a dual solenoid. That means you fire one output from the PLC to tell it to, say, extend, and then you turn it off, it stays put. You use a secondary output to tell it to come back. Okay? And so we refer to that as a dual coil, dual solenoid. And what it means is that if power cuts off, it stays put.
Okay.
Pneumatically. So again, we fire one output, two PLC outputs required. One PLC output tells it to extend, the other one tells it to retract. They have a dual solenoid mode for their electrics.
Oh, wow.
So you just take the same wiring from your PLC and wire it into the control. You don't have to reprogram your PLC. It's really nice.
That is nice.
Then, in pneumatics, we sometimes have a 3-position pneumatic cylinder. And usually to do that, it takes a minimum of 3 outputs. One to extend, one to retract, but then there's a secondary cylinder that you retract it and it goes to mid-stroke. Oh. And so it will give you 3, a fully retracted, a mid-stroke, and a fully extended position. You can do that with pneumatics. It takes 3 solenoids minimum to do that. Okay. 3 outputs from the PLC. They have a 3-position solenoid mode. And so you don't have to reprogram your PLC. That's
huge.
It's huge because when you start screwing with your program on your PLC,
you don't want to do that.
Things can change. Mm-hmm. And a lot of people are just not comfortable doing that. Mm-hmm. Well, CKD gives us the opportunity to do that.
Nice.
in electrics. And so that is from what we call a parallel I/O controller design. The other thing that's true across all their controllers, within each category, parallel I/O or Fieldbus, one controller can be imaged to work with any of their actuators.
Oh, that's nice.
So from a spare parts standpoint, which is a huge point of cost contention within most manufacturers, CKD gives them the opportunity to have one controller on the shelf. So the PIO version of the controller, it doesn't matter if there's like 3 or 4 different sizes, bigger to smaller, small, medium, large, I guess, of the actuators, be it rod or rodless.
Okay.
One controller for all 3. But also, they have rotary actuators that rotate. Same controller for them as well.
Wow, so that really saves on the inventory too.
So you can put one controller on the shelf and cover all of one PIO, if you're doing the PIO series, one PIO controller in your spare parts inventory will cover all of your devices out there. That's huge. And then same thing, if you're Fieldbus, now you can't use a PIO controller to suddenly convert into Fieldbus because Fieldbus can be, again, serial, Profibus, Modbus. I don't think they do Modbus, but Profibus, DeviceNet, CC-Link, so that's serial, so many wires, whatever that is. Or if you're within each one of those, you could have one controller. But if you have a CC-Link, you have to have one of those. If you have a DeviceNet, you have to have one of those. I'm not saying that you can change your Fieldbus.
Okay.
But within those Fieldbus categories, all your CC-Link actuators need one CC-Link controller in spare parts inventory because it can be parameterized parameterized. Is that right? Is that a good word?
I don't know.
You can change the parameters.
There you go.
On the fly with software to say it's not this actuator that it's connecting to, it's now this one. And so that parameterization is something that allows us to use one control within that. But it does have to be CC-Link, or you have to have one for DeviceNet and that kind of stuff. Then we get to the Ethernet-based protocols. And so with Ethernet-based protocols, again, you got to stay within the series, but that's your Ethernet IP, EtherCAT, Profinet.
Okay, and that's one thing I wanted to talk to you today about.
Okay.
Okay, so what's the difference between Ethernet IP and what is it? TCP IP?
TCP/IP or TCP/IP.
Okay.
That is a monster question. I have heard.
Now, did I interrupt you in what you're?
No,
okay.
I've heard that question so much, and I'm ranting, as I listen to and watch videos that I do watch on social media, from TikTok to Instagram to Facebook to Twitter to LinkedIn, I am made aware for various reasons. Well, first of all, there's a lot of folks that are new to the automation industry, just getting started in their careers. And interestingly enough, and I think this is a result of the Great Resignation, but many of them, even though they're just starting in their career, like we're talking about 2 years or less in experience, most of the time, I would think someone with less than 5 years experience would focus on working with someone else to learn the business, to be mentored and things of that nature. But there are quite a few that seem to have just decided, you know what? I'm going to go into business for myself. Now, some of those they just have not been mentored. And so that honestly this is a great platform for that, because that's what we try to do. We try to empower certainly our customers, but everyone with knowledge. And so that's a great question, because whether you're a experienced applications engineer that just hasn't gotten into Fieldbus stuff, or you're a newbie, or of course we hear this a lot. I hear this a lot not from our salespeople, because they know, but from salespeople in the industry. And I've witnessed people getting kind of sold a bill of goods at time, or just misconstruing the differences between when we say that a product supports Ethernet TCP/IP communications, and that being confused with Rockwell Automation's Ethernet IP Fieldbus protocol.
So that's their own specific protocol?
Rockwell developed it.
Okay.
It's now been widely accepted.
Okay.
Globally, and is now it's actually managed by an independent group.
Okay.
ODVA. That's an acronym. I can't remember. It's something DeviceNet, because DeviceNet's where it started. You heard me say DeviceNet earlier. Mm-hmm. That's the serial. Ethernet IP is DeviceNet over Ethernet. Okay. That's really what it is. It's based upon SIP, which is a controller industrial protocol. But Rockwell did create it. Ethernet IP stands for Ethernet Industrial Protocol, was how Alan Bradley Rockwell first marketed it. And it's the most confusing term ever, because of it works over an Ethernet TCP/IP network. So let me try to break this down really quickly. So here we go. Breaking it down. So TCP. What's TCP stand for? I can't remember.
Transmission Control Protocol.
You did your research. One of us is prepared. What is it? Transmission control. Yeah, transmission control protocol. Mm-hmm. And think of TCP as the freight train.
Okay.
not just the engine, but the whole thing.
Okay.
The engine with the cars.
Okay.
And so each car contains stuff that we're moving from point A to point B. That is the transmission control. The train takes stuff. What goes inside the car is the protocol that we're talking about.
Okay.
So Ethernet IP, the industrial protocol means language. Okay. Ethernet IP means we're talking a certain language. So we take the words and we fill up one car with so many words, and we fill up the next car with the next until we get the entire paragraph or sentence, and we send that via TCP/IP.
Via the train?
Via the train. But on the other side, that device has to know that the language that's coming is Ethernet IP, and so it knows how to understand it. If it's not expecting Ethernet IP, or it's expecting Ethernet IP, but what comes is not Ethernet IP language, it doesn't know what to do with it. So Ethernet IP, and that's a very broad description, but Ethernet IP is a specific, what we call a Fieldbus protocol. Fieldbus meaning there's a topology requirement, it has to be connected a certain way, and then also there's a hardware portion to that. So on the connection, that has to do with deterministic or non-deterministic. I'll talk about that really quickly in just a second. And then also has a software or the protocol, the language portion. So these come into play. An example of a non-deterministic protocol would be Modbus. So Modbus by itself, nothing on the end, just if we say just Modbus, that means serial. Modbus TCP is the Modbus protocol language, Modbus protocol over Ethernet.
Oh, okay.
TCP is a train.
Oh, okay.
It's how we move this stuff. Serial would be more like, I don't know, the mail.
Oh, gotcha. Okay.
U.S. Postal Service, something like that. It's slower. So
it'll eventually get there.
Yeah. So serial is a little bit slower, or a lot slower than Ethernet. So it's just two different vehicles to move the data, and the data is whatever language you're talking.
Okay.
So Modbus TCP is Modbus serial, good old Modbus language, but instead of a serial being moved through a serial vehicle, it's moved through an Ethernet TCP/IP vehicle. Okay. Siemens invented Profibus.
Oh, okay.
It's a serial protocol.
Okay.
Fieldbus protocol. Serial moves serially, right? Guess what Profinet is?
Oh, I bet it's over Ethernet, isn't it?
Profibus protocol over Ethernet. So it's moving over TCP/IP. So, and then of course, Ethernet IP, they couldn't call it DeviceNet Net.
No, that'd be weird.
Because DeviceNet, again, sorry, Rockwell, your stuff's confusing at times. So you chose DeviceNet, but it's really serial, so it has nothing to do really, but they were talking about at the time a serial network.
Oh, okay.
And so this is well before, this is going to tell my age, this is well before Ethernet was an accepted means of industrial, moving industrial protocols. So that's, I think this is Brandon talking. I think that's why, if you're setting in, if you go back into your time machine and you set in on the initial meeting, when someone at Rockwell Automation says, we got DeviceNet, but I figured out how to make it work over this new Ethernet TCP/IP stuff. What are we going to call it? And someone says, well, it's industrial protocol, right?
IP.
Let's call it Ethernet/IP. And that's what it stands for. But please, please, please be careful. To all you guys out there who are newer or you haven't had a lot of Fieldbus experience, especially if you're out selling this stuff, don't assume that if you have a device that has an Ethernet, an RJ45 Ethernet port on it, that it supports and will talk to, an Allen Bradley PLC with Ethernet IP, or if it's got an Ethernet port on it, that doesn't mean it's going to talk Profinet to a Siemens PLC. Those kind of things. You need to know what you're doing. By the same token, don't assume that if your device has an Ethernet port on it, that the Allen Bradley will be able to talk to you, because they may not support it may not support Ethernet IP protocol.
Okay.
Does that make sense?
It does. It does. I was going to ask if there's a difference between the TCP IP and Modbus.
Well, Modbus TCP.
Modbus TCP. Okay.
And so, again, Modbus, don't say anything at the end, just Modbus.
Okay. That's serial.
That's serial. So that serial vehicle. Modbus TCP is the name, the trade name for Modbus over an Ethernet TCP IP network.
What do manufacturers typically use?
Well,
that's a loaded question, isn't it?
That is what every controls manufacturer in the whole wide world has tried to use their crystal ball to figure out.
Yeah.
Every Fieldbus protocol has its advantages and disadvantages. Some are faster, some are more efficient, some support certain things and all this kind of discovery and all that kind of thing. I mentioned I would circle back to this. There's the primary difference is there's goodness, I just said what it was. Deterministic and non-deterministic. Modbus is non-deterministic. Ethernet IP, EtherCAT, Profinet, and so I mentioned CC Link was serial. That's the one that Mitsubishi uses. So over Ethernet is called CC Link IE Field. It's a little bit more of a mouthful, but it uses either fiber or copper. And it also, I believe, is deterministic. So what makes a system deterministic versus non-deterministic? What the heck is that? What's the difference? Determinism means that within the system, not that a specific time is always going to be the same, but that if I, in the PLC world, standing at the PLC, inside the PLC, and the PLC says, turn on the output, and that's going across a field bus to a remote I/O station that has an output on it, and that output turns on. The time between the time that I say turn on the output at the PLC reference to the time it actually turns on, they get the message and turn on at the remote station, is what we're calling determinism.
Okay.
So however long that takes, that's how long it will take every single time.
Okay.
Okay? Not that that time has to be within a certain, I don't believe, within a certain that a certain amount or within a certain difference. I don't think that's really where it comes into play. To me, it just means that if it takes 2.65 milliseconds for that output to come on from the time that the main processor said turn on, then it will always take 2.65 milliseconds.
Okay.
Modbus, you don't know. It may take 2.56, it may take 2.3, it may take 3.6.
Wow.
It varies. It's not determined. You can't make that determination. So why is that? How's that difference come into play? I mentioned earlier, Fieldbus. We're talking about Fieldbus. This is called Fieldbus, guys. This is Fieldbus. This is different than hooking your email up, that kind of stuff. Fieldbus protocol, which means it's industrial, number one. Number two, it's a master-slave situation where you have one controller that is talking specifically to nodes, which we call slave nodes, and they're all doing what they're told.
Okay.
So determinism, when the controlling PLC says to the node, do this, how long does it take to do it? That's determinism. With Modbus, you don't have that determinism, you still have the same functionality. So the difference is there's a hardware requirement. Basically, for you and I to have determinism, for me to tell you to do something and you do it, and whether that time to be consistent, then when I tell you to do it, I also need to send you a clock signature, which means you and I both have to have.
We got to be on the same time.
And we have to have wristwatches so we can both tell time. And we can synchronize those watches. So from the time you send them to me to the time that you get it, you're checking your watch and saying, I got to get this done in 2.65 milliseconds. Bam, do it now. Prioritize it, do it. And so you have to have that means of keeping time. So every node on the network has to have the ability to synchronize time and keep time.
Okay.
Modbus, we're not worried about determinism. It's just language. It's just software. So that's why Modbus and Modbus TCP are the most highly supported Fieldbuses globally, second to none.
Really?
Yeah. So mainly because from a manufacturer standpoint, if they're going to put a Fieldbus, if they're going to support a Fieldbus, Modbus is free.
Okay.
And it doesn't require any extra hardware.
Oh.
So a lot of people, a lot, globally, Modbus blows everyone away. Modbus serial or Modbus TCP or both. Not so many people are using, say, Ethernet IP or EtherCAT. But the other thing is you have to buy a license.
For those?
For those.
Okay.
Modbus is free. So your Windows computer is set up to do Modbus.
Oh, really?
So in a research environment, especially in education, they don't have a whole lot of money rolling in.
Yeah.
If it's on the computer, we're just going to use the computer to emulate Modbus and communicate to things. Now, that's not an industrial environment typically, but Modbus is free and it doesn't require specific hardware. You cannot hook your computer up as a node on, say, an Ethernet IP network unless you have a specific card or specific gateway, external or internal, that will allow it to have the hardware to reside on that network.
Okay.
So there's a hardware aspect and a software aspect if you're deterministic. If you're non-deterministic, such as Modbus, software only. But the answer to your question, what's the difference between Ethernet TCP IP and, say, Ethernet IP? And we use those two specifically because they're very close. What I don't often get that question is what the difference between Ethernet IP and EtherCAT or Profinet, because they don't even sound the same.
Yeah.
EtherCAT kind of sounds the same.
Oh, yeah.
But Ethernet IP and TCP IP sound a lot the same.
Yeah.
And so that's why those two, that's probably the most, the question I hear the most, and also the mistake that I see the most, is confusing those two. And what it comes down to, TCP IP. Think of anytime you see TCP, with the exception of Modbus TCP, if just Ethernet, TCP IP. The TCP is the vehicle. What's in the cars is the protocol.
It's a great analogy.
All right. So there you go. So, hey. All right. So that's...
Thanks for clearing that up for me.
That's a little bit of a clear up. I didn't answer your question, which one do most manufacturers use, because it's all over the place.
Yeah.
Obviously. But Modbus is truly more the global standard. But people like determinism as well.
Yeah.
So that's the show for today.
All right.
Kind of short. And so that's the new format we're going to go with this, is kind of talk about some stuff that are educational, which we've always tried to do. And then I'm just going to bring up some stuff that I really think is cool, like the CKD electric actuators and the mechanics side and the electrical side. Yeah, I think that's pretty
And all
pretty
the
neat
little
stuff.
details that they've figured out.
That's right. So welcome back to Season 4. Thanks for checking in with us. Remember, you can listen to us on any podcast streaming app, right?
That's right.
Pretty much any of them. But we've also added, we've always done the Apple podcast, but we've added Spotify.
Oh, where you can rate on Spotify.
Is that what it is?
Yes,
okay.
yes. Listeners can now rate shows that they like on Spotify.
Rate us and review us. Subscribe, ring the bell if you like what you hear. Of course, the video portion is, if you want to watch us as we sit here and talk, is certainly YouTube, on our YouTube channel, LinkedIn, and then Facebook, that's right. Yeah, okay. Yeah. We can do video on Facebook now. So certainly if you'd like to see us as we're recording this, certainly check that in. But this is a new format, Season 4, kicking off 2022.
All right. Woo.
Yeah. So we'll be back in just a few weeks. So stay tuned.
Thank you, Brandon.
See you, Beth. Hey guys, thanks for listening to today's episode of Industrial Automation Doesn't Have To. I hope you enjoyed it. If you did, though, make sure you give us a rating that's pretty doggone high. And do that everywhere you listen to your podcast, including Spotify and Apple Podcasts. We really appreciate it. Also, don't forget our website, www.ellitek.com. That's ELLITEK.com. If you want to reach out to us on our contact form, certainly do that on our website. Or you can email us at info@ellitek.com. And certainly, for those of you that still know how to dial a phone, give us a call, 865-409-1555. We'd love to hear from you.